Let's do a few practice problems. All right, so go ahead and write down number 1. All right, here we go. ln of x equals 5. Well, like I said, to make it look more familiar, we could change this whole ln thing into just log base e of x equals 5. So how would we solve for x here? We want to get x by itself, so change it to exponential form. Yeah, anytime you're trying to solve a log equation and there's a log only on one side, then what you want to do is exponential form. So left, right, middle. What's the left? Right, middle. And there's x. Now you can leave your answer just like that. Now if you want to get a specific answer, you can just type in 2.7 on your calculator, raise that to the 5th power, and you get a decimal answer. It's the same thing, but that's a rounded answer. This is an exact answer. Okay? Let's go ahead and take a look at number 2. Go ahead and write down 2, please. Simplify ln of 1 over e to the 5th. So I'm going to change ln once again to just log base e. And we'll do 1 over e to the 5th. Well, what do you guys think? Subtraction. We could do subtraction because division becomes subtraction, right? So we're going to make it equal to x. It didn't have an x, right? So we can say equals x. And then we can do the exponential form, which would be what? E to the x equals 1 over e to the 5th. Now what? We don't like fractions, right? Do you guys remember how to get rid of those fractions? You move it to the top and you make the exponent a negative. Now that the bases match, what do? Cross it off. And so x equals, there you go. So what are you guys' thoughts for number 3? Okay, so we're remembering that this number being multiplied in the front is like an exponent on the 5. So really what we have then is ln of 25. Okay. What else are we remembering here? Addition becomes what? Multiplication. So I can multiply the 25 and the 4, right? So that would give me ln of 100. Now this part might freak you out a little bit. I don't really plan on testing on it, but there's a little trick we're going to do. I'm going to turn this 3 into a log, and it's going to be a little bit of a magic trick. You guys ready? I can make this 3 times 1, right? You guys got it? I know something with logs that equals 1 when the base matches that anti-log part, right? So, and I want it to be a natural log, right? So ln of what equals 1? E. ln of e is equal to 1 because it's base e matches the antilog, that equals 1. So I'm going to replace that 3 with ln of e. And now don't think, oh my gosh, I should have known that. No, we haven't talked about that yet. That's new. I just thought I'd show you a neat little trick that pops up once in a while in your textbook. So if you didn't know that, don't worry. But now we should know what to do. What happens with this little 3 right here? It becomes an exponent again. So we have now ln of 100 minus ln of e to the 3rd power. And what does subtraction become? Division. So what we have then is ln of 100 over e to the 3rd power. Okay, so we have e to the 2x power equals 9, and we want to solve it. Well, where's my variable? It's in the exponent. How do you solve problems with them in the exponent like that? Change it to log form. So what we have then is log base e of 9 equals 2x, right? Now, what the heck? What am I going to do with that? Well, you could do change of base. You could do log of 9 divided by log of e and get a decimal answer. But at this point, guys, I'm just going to say leave that part alone, because when we work with base e, instead of changing it to a decimal, a lot of times we like to just leave it as an e. But you could do change of base and get a decimal. All right. But all we're going to do is just divide both sides by 2, like this. So here's your final answer. So we are learning some new stuff here. It's not just review. Here's another new thing. With e, let's not change it to a decimal, even though you could, and it would give you the same numerical value. When we're dealing with e, leave it as e. So really, how do you think this answer would look, though, in your guys' textbook? Do you think they would have log base e of 9 on the top? What would they have? They wouldn't have log base e of 9. They would have ln of e. I'm sorry, ln of 9 over 2. This is what would be in your textbook. Okay, because if it's log base e, we don't write log base e. We put ln. We change it to log base e because that kind of makes sense to us based on the rules we learned before. All right, we'll do one more problem. Go ahead and write down number 5, please. What are you guys thinking about number 5?
I think it's hard.
You're a few steps ahead of us. Yeah, it might come out to be a quadratic. What's the first step we're going to do there? Yeah, when you're solving log equations, want to make sure that you have at most one log on both sides. So this is no good. We can't have two separate logs. So addition is going to become what? So I'm going to multiply the x times the x and the 3, and we're going to have ln of x squared plus 3x equals ln of 10. Now, on the other problems, I had one log only, so I had to change it to exponent form. What do you do when you have a log on both sides? You just cross it off. You can ignore it. So what we have then is x squared plus 3x equals 10. And so, yes, you were right in saying it's going to be a quadratic equation. So we need to use a quadratic formula. So that's where we're at right now. Okay, here we go. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So this is going to be 9 minus negative 40, which is positive 49. Square root of 49, that's a nice one. That's what? 7. And then we're just going to split this up into two separate problems. Negative 3 plus 7 over 2 and negative 3 minus 7 over 2. And we'll simplify both of them. So there's your two answers for x, 2 and negative 5.